We're going to be talking about slopes and why they're important. In order to do that, let me start off with an example. Let's say, for example, I have a graph and I'm going to let the x-axis represent the displacement, and the units for that are going to be in meters. So represented by m over there. And my x-axis is time, and it's going to be measured in seconds. So let's say if we're starting from your house and the position of your house, let's just call that 0, and at time 0 you are at your house, so it's going to be measured by that dot over there. Now, let's say if you're walking away from your house at a constant pace. So let's say for every 2 seconds you move 1 meter away from your house, and I'm going to plot that over there. So for the 4th second you're going to be 2 meters away from your house, and I'm going to plot that over there. And for the 6th second you're going to be 3 meters away from your house, and I'm going to plot that over there. So you can observe that clearly this is sort of a linear equation, and I can draw lines through these points and I can see that it is a linear equation. In fact, it's almost perfect. It is perfectly linear. Now, what if I wanted to measure the rate at which I was walking away from my house? So in order to measure that, that is actually the slope of this function, and we'll see why in a second. Now, but how do we measure slope first? The slope, as you recall, is the rise over the run, or in other words, the change in the y over the change in the x. So in this graph, for example, in this function, if I draw it over here, this is my rise, which I'm going to be delta y, and this is my run, which is delta x. So, and the equation for this was y2 minus y1 over x2 minus x1 x. And I'm just going to pick 2 points. I'm going to say this one, and the coordinates of these are 6 and 3, and the lowest one, the coordinates of which are 2 and 1, and this is x1, y1, and this is x2, y2. So if I want to calculate it, it'll be 3, my y2 is 3, minus 1, and this is measured in meters, right? Whereas the x2, which is 6 seconds, minus 2, and I'm going to write seconds for that. So this is going to be 2 meters over 4 seconds, which is half if you observe, and that's going to be 0.5 meters per second. So right here, as we can see, the slope gives us the speed at which we are walking away from our house. So it's 0.5 meters per second. So it's the rate of change with which we are moving away from our house. Now, I designed this carefully such that it was a linear equation. So we're moving away at a constant rate. Now, what if we were moving away at a rate that was not exactly constant? So let's take a look at that. So I have this. So let me draw another graph. And so now let's just say, once again, the x is going to be distance, so that's going to be meters. Sorry, that's the y. The x is going to be time. It's going to be measured in seconds. So let's say once again, I start from 0, 0. And once again, 2 seconds after, I guess I'm moving away. But now, so after 2 seconds, I'm 1 meter away. However, let's say in the next 2 second interval, I am, instead of being 2 meters away, let's just say I'm double that. So let's say I'm 3 meters away. So instead of 1 meter, a 1 meter change before, now it's a 2 meter change. Okay? And now let's say if I move one more time, so in the next 2 second interval, so now I'm the 6th second, instead of being 3 meters away, let's just say I am 6 meters away this time. So in other words, my point is like that. Which means that for every 2 interval period, I'm actually moving much farther away than from my house, as opposed to walking previously at a rate of 0.5 meters per second. So if I connect these dots, you can see that's no longer a linear equation, but it's sort of a curve moving upwards. In other words, I'm accelerating away from my house. So let's say if I wanted to measure the speed at each of these points. I know it's not exactly the smoothest curve, but forgive me there. So let's say, for example, at the 2-second mark in this second situation, I wanted to measure the speed at which I was at the 2-second mark. So as we said before, this is represented by the slope. So my speed would be something like that. It's like the slope at that point. What about the 4-second mark? My speed at that point is going to be a little bit steeper because I'm moving away at a faster rate. Finally, when I'm at the 6-second mark, my speed at that point is going to be whatever that is, but it's going to be much faster than it was than at the previous two intervals. So the question becomes, how do I measure the speed when my graph is not linear? And this is the whole point of slopes, that we want to measure this. We want to measure the rate of change. What a slope is simply a rate of change at each point on the graph. And in the next video, we will discuss how we can find out the slope at each point. In other words, find the rate of change. The slope is nothing but the rate of change at each point on a function.